Hi, and welcome back. So let's keep doing some more final exam prep questions. So for the next few videos, I'm going to do a few on stoichiometry. So in this example, I'm going to give you this equation. So we're going to deal with the equation where we have two, oh, I think I'm still, there we go. So we've got 2 SB solid plus 3 sulfur solid will yield 1 mole of Sb2S3 solid. And the question is this. Say we start with, let's say, we start with 1.97 grams of Sb, which is antimony, or I forget, I don't know if this is antimony or antimony or how you pronounce it, but we start with 1.97 grams of Sb, and we end up producing 1.26 grams of this. So we end up producing, this is going to be 1.26 grams of Sb2S3 is what we end up producing. And what we are looking for is, there it goes. What we are looking for is the percent yield. So anyway, if you want to, did I spell yield wrong? Anyway, I guess it doesn't matter that much. But if you want to try to figure this out yourself, pause the video now because I'm going to start working through this. So to begin, we have to figure out, let's get all of our molar masses, and we actually don't really need to do too much for antimony or sulfur, but let's just go ahead and figure out what the molar mass would be for Sb2S3. So antimony is right here on the periodic table, and sulfur is right here. So let's just go ahead and figure out, let me get out my calculator. And so antimony is going to be 121.76, and we are going to multiply that by 2. And then we're going to add to that, and I'm actually going to do this with parentheses, 32.065 multiplied by 3. Close my parentheses. And so it comes out, our molar mass for Sb2S3 is going to be 339.715. So let's say this molar mass, and I'll do this in purple. So molar mass of Sb2S3 is going to be, what did I say it was again? 339.175. So it's going to be 339. Oh, did I say 715? Yeah, 715. 339.715. Hopefully you can see that. Sorry, that's getting kind of squished over there. So now let's figure out how much of this stuff we should have made. So we're going to start out with 1.97 grams of antimony. So 1.97 grams times the molar mass of antimony, which is going to be 121. So we have times 1 mole is going to be 121.76 grams. So 121.76 grams. And then let's multiply this by our ratio. So we are going to, for every 2 moles of antimony that we put in, we're going to get 1 mole out of our product. So let's just arbitrarily change colors. So for 1 mole, and I should say 1 mole of antimony, we are going to get out, for every 2 moles of antimony that we put in, we are going to get out 1 mole of Sb2S3. Okay, so then let's figure out how many grams that would be, and I'll just keep working down here. So now we would say 1 mole of Sb2S3 is going to give us 339.715 grams, so 339 2.715 grams. And how much is that going to be? Let's get our calculator out again. There we almost go. Okay, so we're going to take 1.97 divided by 121.76, then divided by 2, and then multiplied by 339.715. And we get out 2.75 about. So 2.75. And you also might have noticed I wasn't putting in any of the ones into the calculator because multiplying or dividing by 1 just gives you the same number. So anyway, this is our theoretical yield is going to be 2.75 grams. So our theoretical yield, all of this is going to be 2.75 grams. But remember, we only actually got 1.26 grams out of this reaction. So what we have to do to figure out our percent yield? Well, we have to divide, I'll give myself a bit more room, we have to divide how much we actually got by our theoretical yield. So our percent yield is going to be our actual yield over our theoretical yield. So I'll just write that down. Our percent yield is going to be actual yield over theoretical yield, and then we're going to multiply that by 100 to actually turn this into a percent. So this would be, let's plug in our numbers, we have 1.26 grams divided by our theoretical yield, which is how much we could have gotten if all of these, if we had gotten 100% efficiency from this reaction. So our theoretical yield is 2.75 grams, and then we're going to multiply that by 100, which will give us our percent. And let's go get the calculator again. Calculator, and so we have 1.26 divided by 2.75. That's going to give us 45.8, and then I'll just go ahead and multiply that by 100. So this is going to give us 45 and we're doing this with we have three significant figures for this operation. So this reaction has had a 45.8, write that down, we had a 45.8% yield. So that is our final answer. Hopefully you found this useful, and I'll see you in a future video.